important question of compiler design, part second class actually. Fine. So I think hope you are ready. Okay. Okay. Okay, fine. So this is my Telegram group, fine. And if anyone interested, you can join my Telegram group where I can share the link also, and I can share my PDF notes also. And if you want anything more, if you have any doubt regarding the class, you can ask me. Okay. And if you have doubt in any subject also, you can ask me. And my dear friend, UPSC ESE 2023 mains results has been out. Fine. If you have any friends who have already qualified, you can ask them, and you can and they can share their result, and they can get free mock interview with our expert panel. Hello Satya. Hello everyone. So yeah, already we have, see here in last class we have discussed my dear friend about lexical analyzer. So only for the revision I have given this, only for the revision purpose. Then I will start our next part. So can you please tell me in the first one, second one, third one, fourth one, how many tokens are there? Can you please tell me? I'm waiting for 1 minute. You can please tell. 4 questions. Please tell me how many tokens are there. I just want to know the how many tokens. Everyone please reply. Everyone please reply, my dear friend. Please reply. Okay, someone telling 1 is 6. 1 is 6. Okay. Okay. Do fast. Do fast. Do fast. Okay, so I'm counting here. See here. 1, 2, 3, 4, 5, 6. So 6 is the right answer. Very good. 6 is the right answer. 6 is the right answer. Okay. Now see clearly about second one. Int is a keyword, X is an identifier, separator 3, identifier 4, operator. So how many we have? 1, 2, 3, 4, 5, 6. So here also we have 6. See clearly, here it will consider as an operator, star and what? Division. Fine. Is that clear, my dear friend? So here also we have a 6. Okay. What about this one? See here. What about this one, my dear friend? In third one. So third one, my dear friend, can you please tell me third one? X plus equal to 2, 3, 4, 5. So yes, we have 5. We have what? 5. What about this one? 1, 2, 3, 4, 5. So we have what? 5. Fine. Is that clear? Is that clear, my dear friend? I think this one is the answer for counting the number of tokens. Number of tokens, my dear friend. I think this one is clear. This one is clear. This is very simple, because maybe if you are lucky or unlucky, 1 mark question will come from counting the number of tokens. Fine. So you don't have any confusion regarding this. Fine. Okay. Maybe they will ask which of the following have single token. Maybe. Let me give you some option. Which of the following have single token? Like plus plus. Fine. Second one. Let me write here. Star. Fine. Can you please tell me which of the following is a single token? I think everyone know. Fine. The single token is here. This is single token. This is what we have 2 token. This is one operator OP1, and this is what OP2. This is what OP2, my dear friend. Here we have how many tokens? Here we have what, my dear friend? 2 tokens. 2 tokens, my dear friend. See clearly. Maybe I will write some example like main. Let's suppose main and open parenthesis is there, and I'm writing here like let me write int x semicolon. I'm asking you how many tokens are there. How many tokens are there? This is curly braces. You can curly braces. Fine. How many tokens are there? Here tokenization will be done. Tokenization definitely will be done by the lexical analyzer. See 1, 2, 3, 4, 5, 6, 7. Here we have 7 tokens, but it will give syntax error. It will give syntax error because see here this closing parenthesis is missing. Fine, missing. Maybe if I will miss this one, it will give syntax error. If I will miss semicolon. Let's suppose semicolon is not there. Semicolon is not there. It will also consider as a syntax error. Okay. Second example, yeah. Yeah, it will not to comment, my dear friend. It will see here. Intensely I have written this example. Fine. Intensely I have written this example. If in multi-line comment, if closing and ending is there, then you can consider lexical analyzer will recognize the comment and what? Simply what? Ignore it. Ignore it. Are you getting my point? Ignore it. But here it will be considered as identifier. This is identifier. This is operator. This is operator. Are you getting my point? I think you are aware about multi-line comment. So there should be a starting and ending. And between this whatever coming, it is what? Comment only. Are you getting my point? So it is not comment at all. Here it is not comment. It is not comment. Intensely I have written. Fine. Comment लिखने से वो comment नहीं बन जाएगा. मेरी बात समझ रहे हैं? सिंगल लाइन कमेंट हो, मतलब सिंगल या तो सिंगल लाइन कमेंट लिखा हुआ फाइन, या मल्टी लाइन कमेंट हो फाइन, इसके अंदर जो भी चीजें लिखी हुई हैं ये क्या होंगी? कुछ भी लिख दो, कुछ भी राम कहानी, वॉट एवर यू राइट हियर, इट विल बी व्हाट माय डियर फ्रेंड, इट विल बी व्हाट? रिकॉग्नाइज्ड बाय द लेक्सिकल एनालाइजर एंड व्हाट? इग्नोर. सिंपली इग्नोर. वॉट एवर बिटवीन मल्टी लाइन कमेंट इट इज, they will ignore. Are you getting my point? Here it will be considered as an operator. Here it will be considered as operator. Okay, one more question I'm asking here only. Which of the following will give error? Maybe they will ask. Which of the following will give lexical error? Fine. So if I will write C, A option, let me write here 1. B option. Fine. 1A. Can you please tell me which of the following, semicolon. Only 2 options I have given. Fine. Can you please tell me which of the following will give lexical error? A or B? 1 or 1. Let me write here 1 semicolon, 1A semicolon. Which of the following will give lexical error? If I am asking to you, A or B? A or B? Which of the following will give lexical error? Yes, B only. Yes, Satya. Very good. B only will give lexical error. Fine. This will consider as a constant. Constant and what? Separator. So here we have 2 tokens. Here we have 2 tokens. Here 1 semicolon. Here we have 2 tokens. One as a constant. This one is a separator. And here, my dear friend, it is what? Not a valid identifier. Not a valid identifier. Fine. It will give lexical error. So I told you very clearly, whenever lexical error is there, do not count the number of tokens. Do not count the number of tokens whenever lexical error is there. Are you getting my point? Okay. So I'm moving now. So yeah, in this class we'll discuss grammar. Fine, grammar. So everyone know grammar is nothing but the set of rules which are used to generate the string. Fine, the set of rules which are used to generate the string. So in grammar we have 4 tuples. See clearly here. We have variable, we have terminal, we have production, and we have a start symbol. So in grammar, we have this 4 terminals, 4 tuples, set of all non-terminal or variable. V is known as set of non-terminal, or you can say variables. So generally variables are denoted by the capital letters. Fine. T is nothing but set of all terminals, means all small letters, you can say all terminals. P means set of all productions, all production, all rule. And S means the starting symbol. So in grammar, we have what? The starting symbol also. So we have 4 tuples in grammar. Just I am giving the idea. Behalf of that, we are able to solve some problem. So I'm giving you idea about grammar. Fine, because in grammar, we have less number of questions also, but you should know. So what is derivation, my dear friend? So derivation is nothing but the process of deriving a string is known as derivation. And the graphical representation of the derivation is called a derivation tree or parse tree See clearly, the process of deriving a string. Deriving a string is nothing but derivation. And the graphical representation of the derivation is known as derivation tree or parse tree, my dear friend, or parse tree. Okay. Now, see, now we have 2 types of derivation. One we have leftmost derivation and one we have rightmost derivation. Fine. The meaning of leftmost derivation means, see, the meaning of leftmost derivation means expansion of leftmost variable first. Expansion of leftmost variable first. The meaning of rightmost derivation means expansion of rightmost derivation. Rightmost variable first. Expansion of rightmost variable first. Okay. This is very simple terms. Now, see clearly leftmost derivation. The process of deriving a string by expanding the leftmost variables. Variable, or you can say non-terminal, is called what? Leftmost derivation. And the graphical representation is called leftmost derivation tree. Leftmost derivation tree. Let's suppose if S goes to AB, fine, let me write some simple grammar, fine, and let's A goes to A and B goes to B, fine, B goes to B. So my dear friends, see clearly here, S goes to what? AB, S goes to what? AB. What is leftmost between A and B? A and B, A. So see here, I'm expanding A, this one, A then B, A then B. Then what? B, my dear friend, that is nothing but AB. Fine, this is nothing but leftmost derivation. What is leftmost derivation tree? It is nothing but S goes to AB, fine. Then first what? I will expand A, this one, so A goes to A, fine. Then you can write here B goes to what? B. B goes to what? B. So it is nothing but leftmost derivation. Leftmost first. See, if you traverse, see A, then what? We have B. AB. Fine, AB. Is that clear? I think leftmost derivation is clear. Okay, I'm moving now. See, rightmost derivation. So the process of deriving a string by expanding the rightmost terminal, rightmost non-terminal, because only you can expand terminal, expand non-terminal or variable only. So it is nothing but, my dear friend, rightmost derivation, and the graphical representation is known as rightmost derivation tree. So in the same example, if you talk about, if I will expand B first, this is what leftmost. What is rightmost? See, S goes to AB. What is rightmost between these two? B. So first B, so AB. Fine. Then we have only one variable, so AB. So this is nothing but, my dear friend, rightmost derivation. Fine. What is the graphical representation? S goes to AB. First we expand what? B. Then we expand what? A. It is nothing but rightmost derivation. Okay. Now, see clearly. So I think we have done leftmost and rightmost. So based on the number of derivation tree, grammar can be classified in two types. So we have ambiguous grammar and unambiguous grammar. Fine. Now the problem has been started. Now they will ask question from here also. Be there for 1 more minute. Definitely you are able to solve some problem. See, ambiguous grammar. What is the meaning of ambiguous grammar? The grammar G is said to be ambiguous if there exists more than one parse tree for at least one input string. For at least one input string, if we have more than one parse tree. For at least one input string, if we have more than one parse tree, it means the grammar is ambiguous grammar. Grammar is ambiguous grammar. What is the meaning of unambiguous grammar? The grammar is G said to be unambiguous if there exists only one parse tree for every input. See here. Here for every input, if we have at least one parse tree, it means it is unambiguous. And for at least one input, for there exists one input, if we have what? More than one parse tree, it means it is what? Ambiguous grammar. Are you getting my point? Okay. There exists one input string. Fine. For some input string, if we have more than one parse tree, it means it is ambiguous. Fine. Otherwise, it is unambiguous. Unambiguous means for all input, there should be one parse tree. Fine. Okay. So I think it is clear. So I'm moving now. Now, based on the string generated, the grammar is classified into two types. We have recursive grammar and non-recursive grammar. Fine. We have recursive grammar and non-recursive grammar. Okay. So what is recursive grammar? So the grammar which contain at least one recursive production is called recursive grammar. So the grammar which contain at least one recursive production, it is called recursive grammar. Fine. And the grammar which is free from recursive production is called non-recursive grammar, which is free from recursion, which is called what? Non-recursive grammar. Fine, means at least one variable should be common in left and right hand side. So you can say it is what? Recursive grammar, else it is non-recursive grammar. Okay. Now, see clearly. So we have two types of recursive grammar, left recursive grammar and right recursive grammar. Left recursive grammar and right recursive grammar. What is the meaning of left recursive grammar? See clearly here. I'm writing here. A goes to A alpha oblique beta. A goes to A alpha oblique beta. So my dear friend, A alpha oblique beta. See clearly in right hand side, if leftmost variable is same, it is nothing but left recursion. See, in right hand side, see leftmost variable. What is leftmost variable? A. It is same only. It is nothing but my dear friend, left recursion. What is the meaning of right recursion? A goes to A oblique B. It is nothing but, see here, this is nothing but right recursion. In right hand side, if rightmost variable is same, in right hand side, rightmost variable is same, is nothing but what? Right recursion or right recursion. Fine, right recursion. Okay. Now, see, if we apply leftmost derivation on left recursion grammar, then parser can go into the infinite loop. See clearly. If we apply leftmost derivation, then what happens? The parser will go into the infinite loop. Okay. And if we apply leftmost derivation on the right recursion, fine, then there is no problem. There is no problem of infinite looping. Fine. And you know, top-down parser use leftmost derivation. It will start from the start symbol and goes to the string. So there is a problem when top-down parser will meet to the left recursive grammar. Fine. When top-down parser will meet to the left recursive grammar. Let me tell you how. See clearly. See here. What is left recursion? You know, A goes to A alpha oblique beta. If leftmost variable is same. A goes to A alpha oblique beta, my dear friend. What is happening if we will meet to the top-down parser? See clearly. See, it is nothing but, see here, it is nothing but, my dear friend, A is calling A and doing some alpha computation. Are you getting my point? Doing some alpha computation, my dear friend. See here. So if you're writing any recursive program, there should be a termination condition first here. There is no termination condition here. You don't know where to stop, when to stop. Are you getting my point? So what is happening here? It is always what it will do. A goes to A alpha. Fine. A goes to A alpha. Fine. It will not count. See, parser will read only one input at a time. It will not count how many alpha after A. So what it will do, it will go into the infinite loop. But it will what? Expand like this only. The problem with this, when top-down parser will meet to the left recursive grammar, it will go into the infinite loop. It will go into the infinite loop. It will not count after A how many alpha are there. What it will generate? It will generate A. See, A followed by alpha star. See, if you replace A by beta, what it will generate? It will generate what? A goes to beta alpha clen closure. Beta alpha clen closure. Am I right? Beta alpha clen closure. Am I right? Yes. Beta alpha clen closure it will generate. Fine. So the problem is this, when a top-down parser will meet to the left recursive grammar. But there is no problem with right recursive grammar. If I will take this grammar, see, if top-down parser will meet to the right recursive grammar, what is happening? See clearly, A goes to, see, alpha A. So how many alpha you want? See, how many alpha you want? See, if you want to generate only one alpha, you can stop here. Alpha, beta, you can stop here. If you want two alpha, so you can expand once again. A goes to alpha A. Fine. Are you getting my point? So here we know like how many alpha is coming before it. Fine. So there is no problem when my dear friend, when right recursive grammar will meet to the top-down parser. Is that clear, everyone? Fine. Hope it is clear. It is very easy. It will help you in question. I am giving you question. Fine. Only 5 minutes more, theory will be finished. So left recursive grammar we have done. Okay. And see, now grammar with common prefixes. Grammar with common prefixes, my dear friend. So it is nothing but grammar with a common prefix is known as a non-deterministic grammar. Grammar with common prefix is known as a non-deterministic grammar. Let's suppose, see clearly here, what we have. Let's suppose we have A goes to A alpha 1, A alpha 2, A alpha 3. Point, see clearly. If you see this grammar, my dear friend, what is happening here? See, all prefixes, A is common here, A is common here, A is common here. Are you getting my point? A is common in all production. See clearly. A alpha 1, A alpha 2, A alpha 3. First letter is common. First letter is what? Common, my dear friend. See clearly, if I want to generate W equal to A alpha 3, my dear friend, as a human being, you know, this production will give the right answer. But my dear friend, parser is not intelligent enough. Fine, parser इतना intelligent नहीं होता है ना. Fine, वो क्या करेगा? पहले production को उठाएगा. Fine. Okay, fine. A goes to A. It will match. Now it will go for what? Alpha 1. It is not matching. Backtrack. Choose another production. Then A goes to A. Fine. A alpha 2. Not matching. Backtrack. Then A goes to what? A alpha 3. Finally, it will what? Match. Are you getting my point? So see clearly here we have problem. Problem of what, my dear friend? Same prefix in every grammar. So this problem is nothing but non-deterministic grammar. You can say common prefix problem. So you can solve, what you do, you make your grammar is what? Left factored. You make as grammar is what? Left factored grammar. So your grammar should be what? Left factored. How you can make left factored? See what you do, you can do like this. A goes to A dash. And what is A dash goes to? A dash goes to alpha 1, alpha 2, alpha 3. Fine. Alpha 1, alpha 2, alpha 3. Now see here, no common prefix here. See here, all are fighting. If I will tell, like, I will give this beautiful pen, or you can say virus pen. Fine. Those like जिनका नाम A से start हो रहा है. So all are telling, sir, I am the one. All are fighting here. Fine. So if there is fighting, my dear friend, if there is a fighting, it means like we have a problem of common prefix. So what we do, we need to make left factored. We need to make it deterministic. So see here, we will convert in the deterministic way. Fine. So this grammar is what? Non-deterministic. Now we have converted into the deterministic grammar. Fine. So I think we have written already. If the grammar has common prefix, then it involves a lot of backtracking. Fine. Backtracking is costly also. To avoid backtracking, हमने क्या करना होता है? हमें deterministic grammar बनाना होता है. Okay? Fine. Now, left factoring I told you already. Fine. Okay. So I'm moving. Now, this one we will see tomorrow also. Based on that one, already question has come in exam. See, we have two type of parser. Top-down parser, you know, start from the start symbol and goes to the string. Bottom-up parser, you know, start from the input or a string and goes to the start symbol. So in top-down, we have with backtrack, that is brute force technique, fine. And without backtrack, that is called predictive parsing. It is two types, recursive descent parser and non-recursive descent parser. That is nothing but LL1. LL1. That is nothing but LL1. We'll see tomorrow what is LL1, fine. And bottom-up parser, we have operator precedence parser, and we have LR parser. LR parser is LR0, SLR1, CLR1, and LALR1. Fine. And we'll see each and everything. Fine. Okay, definitely I will send. So this see here, this diagram is required. They will ask you, see here, this is the only parser, operator precedence parser, which will parse both ambiguous and unambiguous grammar. See, operator precedence parser is the only parser who will parse ambiguous and unambiguous grammar. Fine. Is that clear? See, how bottom-up parser will work? I think everyone know. Reverse of rightmost derivation. Reverse of rightmost derivation. This is nothing but leftmost derivation. LMD. This is nothing but reverse of rightmost derivation. RRMD. Fine. Reverse of rightmost derivation. Bottom-up parser will work reverse of rightmost derivation. Start from the bottom, start from the string, and goes to the start symbol. Fine. Okay. Now see clearly, in all parser, my dear friend, top down and bottom up, which one is powerful? Bottom up parser is powerful. Fine. In bottom up parser, which one is powerful? More powerful CLR. More powerful CLR. Then after CLR, LALR. Then what? SLR. Then what? LR0. Are you getting my point? I will tell you in tomorrow and day after tomorrow class. Don't worry. Fine. I will tell each and everything. So just the glimpse I have given here. Fine. So that you are understood at least. I will tell each and everything. Fine. Is that clear, my dear friend? Please reply. Please reply. Fine. A double L, what is the meaning? LL1 का meaning क्या होता है? What is the meaning of LL1? Left to right. Scan what? Left to right and leftmost derivation. Scan left to right. And one input at a time. One input at a time. Fine. They will ask, what is the meaning of LR? They will ask, what is the meaning of LR? Fine. Everything they will ask in the exam. Okay. We'll see tomorrow, not today. Today we'll see only grammar. Okay. So can you please try this question? Can you please try this question? What is the answer of this one? Okay. Now we have 25 minutes and we'll solve question only. Fine. Can you please tell me what is the answer for this one? Consider the following expression grammar, and they have asked which of the following grammar is not left recursive but is equivalent. See, grammar should be equivalent. If you are converting any grammar into the non-left recursive form, it is nothing but, my dear friend, it is nothing but, it is what? It should be equivalent. It should be equivalent also. What is the answer? Can you please let me know? Here the option here, if it is not C option is not mentioned, not clear, not visible properly. So y goes to plus fy oblique null, and f goes to opening bracket e. I'm writing here. F goes to opening bracket e, closing bracket id. Fine. That is the option. Okay. Someone telling C. See clearly here. So this grammar is here, left recursion. This grammar is what? Left recursion. Fine. Here no problem. In third one, no problem here. Fine. So I think everyone know. A goes to A alpha oblique beta. Fine. How to convert this one? A goes to what, my dear friend? Beta A dash. I want beta. So beta followed by any number of alpha. Beta A dash, and A dash goes to what? See, alpha A dash oblique what? Null. Fine. Alpha A dash oblique null. Is that clear? A goes to alpha A dash oblique null. Okay. Because I want single beta, that's why I put null here. See, E goes to E minus T oblique T. If you want, see here. If you want, you can remember the rule, but rule is not required. Okay, what is beta here? So E goes to, it is nothing but, see here. So they have taken X actually. Fine. They have taken X. So you can take any variable. Here I am taking A dash. You can take any variable. So E goes to, see here. So I'm just here. They have, see, if you want, you can check also. It should be equivalent. Let me write in terms of X. So E goes to what? TX. See, E goes to what? TX. See clearly. Now E goes to TX. Now X goes to what? X goes to what? See here, minus T X oblique null. Minus T X oblique null. Are you getting my point? What about this one? T goes to. See, I will write Fy in terms of Y. And what is Y goes to? Y goes to plus Fy oblique null. Y goes to what? Plus Fy oblique null. And here we don't have any problem. You can copy and paste here. You can copy and paste. So option is what? C. It is very easy question. See, this is your favorite grammar. E goes to E plus T oblique T. Here they have written minus here. Okay, if I will ask which of the operator have higher precedence? See here, which of the, we have two operator here. Which one of the operator have higher precedence? किसका precedence ज़्यादा है? माइनस का या प्लस का? इसके अंदर इस ग्रामर को देख के आप ये भी बता सकते हैं कि किस ऑपरेटर का प्रेसिडेंस ज्यादा है. See clearly here. So those operator is farthest from the start symbol, which having higher precedence. So for looking this grammar, you can conclude plus is higher precedence than minus. Plus is higher precedence than minus. Fine. And my dear friend, see, if we have 2 plus, see, grammar is, see here, if the grammar is left recursive, it means it is left associative. So minus is what? Left associative. And plus is what? Plus is what, my dear friend? Plus is also left associative. If the grammar is left recursive, it is what? Left associative also. Fine, you can conclude from here also. Okay. I'm moving now. Okay, this grammar, this question they have given the tree here. Fine, they have given the syntax tree here, parse tree here. Or you can say this is syntax tree. Fine, because operator or the root only. Fine, operator or the root. Fine. Even they have written parse tree. Consider the following parse tree for the expression, this one, involving 2 binary operators. So we have 2 binary operators, dollar and hash. Which of the following is the correct for the given parse tree? Can you please tell me? Option A, option B, option C, option D. I'm waiting for the response. Please reply. Please reply quickly. What is the answer for this one? Now they have not written the grammar. They have given the parse tree. Quick, quick. What is the answer for this one? Okay, see the parse tree, my dear friend. See the parse tree, my dear friend. See in parse tree also, if you see clearly here, fine, किसका evaluation पहले हो रहा है? Fine, grammar में नीचे कौन सा है? या कृष्णा, you are correct. Grammar में देखो सबसे नीचे कौन सा है? देखो dollar, my dear friend, dollar. Fine. See which one is farthest from the start here also. Here you can see farthest from the root. Dollar, my dear friend, dollar. Fine. See first you traverse like this only. So first what will happen? This dollar will be evaluated. After dollar, see this dollar will be evaluated. After this one, hash will be evaluated. After this one, this hash will be evaluated. So my dear friend, if you see clearly, so among these $2, among dollar and hash, we have only 2 operators. So which one is evaluated first? This dollar only. This dollar only. See clearly, this dollar only, my dear friend. So see $C will be evaluated first. So $C. So among this one, see this $C will be evaluated. $C will be evaluated. Are you getting my point? $C will be evaluated. Fine. Now see clearly. So, and my dear friend, among these, if you have $2 also, my dear friend, $2 also, which dollar you are evaluating first? See clearly, if you have $2, $C and $C. So leftmost is what? Leftmost. This one is evaluating first. So it is nothing but left associative. Left associative. See here, we have $C and $C. So among C, we have $C, and then the result of this one will be what? Will be evaluated to the D, my dear friend. So it is what? Left associative also. Now, my dear friend, if we have 2 hash, see this is in right. This is in right. So hash is nothing but rightmost, my dear friend, rightmost. So I think in option, yeah, dollar is higher precedence than hash, and it is left associative, and dollar is what? Right associative. So answer is for A. A is the right answer. A is the right answer. Fine. Is that clear, my dear friend? See, if you have $2, see, right one is evaluated first. Right one is evaluated first. See clearly. First we evaluate this one, first evaluation. Then this is second one, my dear friend, second one. Then this is third one, and this is fourth one. Are you getting my point? This is fourth one. So this is C. Right one is evaluated first. If we have 2 hash. Fine. I think it is over. Okay. I'm moving to next question. Okay, this one. Can you please tell me? The last option is 12. The last option is 12 they have written. The last option is 12 they have written. Can you please tell me what is the answer for this one? 2 minus 5 plus 1 minus 7 into 3. Fine. Can you please tell me? They have written clearly. Plus is having higher precedence and plus is left associative. Fine. Minus is medium and it is right. And multiplication is what? Low and it is left. And they have input given 2 minus 5 plus 1 minus 7 into 3. Okay, 9. Someone telling 9. So plus is having the higher priority. So it is nothing but 2 minus 6 minus 7 into 3. So, and minus is nothing but, my dear friend, right associative. Minus is nothing but, my dear friend, right associative. Right associative because they have written minus. So this one we evaluate first. It is nothing but 2 minus, fine, this is minus 1. This is what? 2 minus minus 1. I can add 2 plus 1 into what? 3. Fine, now what we have? 3 into 3. It is nothing but 9. So 9 is the right answer for this one. 9 is the right answer for this one. It is the gate question only. Okay. Okay. Can you please try this question? What will be the resulting grammar after removal of left recursion from the following grammar? What is the answer for this one? Can you please tell me? What will be the resulting grammar after removal of left recursion from the following grammar? What is the answer? Can you please reply? Here, left recursion, my dear friend. Left recursion is here. Left recursion is here. Can you please tell what is the answer for this one? Okay, someone telling D. Krishna Rao is D. Anyone else? D. Okay, anyone else? See clearly, it is what? See, here we have what? You can write it is nothing but beta 1 and beta 2. You can consider beta 1 and beta 2, my dear friend. Okay. So it is nothing but what you can write. You can write E goes to what we have. Sorry. We can write E goes to AE dash, fine. And oblique BE dash. And my dear friend, E dash goes to what? E dash goes to what we have? We have A and what we have? We have B. Fine. We have what? A and we have what? B. And what we want? We want null also. Fine. Okay. So I think matching option is nothing but, yeah, D for Delhi is the right option. D for Delhi is the right option. Okay. Very good. So, which of the following derivation does the top-down parser use while parsing an input string? The input is assumed to be scanned in left to right order. I think everyone know. Already I told. What is the answer for this one? What is the answer for this one? Tomorrow onwards, you will also more enjoy actually, because like more question will come, because more question will come from LL1 and my dear friend bottom-up parser. Fine. Parsing, you can know, parsing is the heart of compiler. So more question will come from there and SDT, my dear friend, nowadays. Okay, yeah, A is the right option. Fine, leftmost derivation. Okay, now see, which of the following suffice to convert an arbitrary CFG to an LL1 grammar? Okay, I have asked here, but yeah, you should know about this one. Which of the following suffices to convert an arbitrary CFG to an LL1 grammar? LL1 grammar. Removing left recursion alone. Factoring the grammar alone. Or removing left recursive and factoring the grammar, or none of the above. What is the answer for this one? Can you please reply? So the answer for this one is C for Chennai, my dear friend. See clearly. See, if any grammar is, my dear friend, see, if any grammar, trust. Okay, because maybe ambiguous grammar. See, according to the option, my dear friend, see, okay, any ambiguous grammar cannot be parsed by LL1. You are right. Yes, it may be ambiguous grammar, but here what they have asked, accordingly you can go. See, removing left recursion alone is not a solution. Factoring the grammar alone is also not a solution. Fine. So my dear friend, you can choose removing left recursion and factoring the grammar is what, my dear friend, is, you can say, is suffice to convert an arbitrary CFG into the LL1 grammar. Yes. So if the grammar is ambiguous, it cannot parse by any of the grammar. Either it is bottom-up parser or top-down parser. If the grammar is ambiguous, my dear friend, it will not parse by any one of the grammar. Fine. See clearly, if the grammar is ambiguous, definitely, my dear friend, definitely it will not pass by any of the grammar. See clearly. Let me ask you, see, I think everyone know also, if I will write this grammar, your favorite grammar, E goes to, see, let me write this one, E plus E, E star E, E star E, ID. I think everyone know this grammar is what? This grammar is what? This grammar is what? Ambiguous grammar. This grammar is what, my dear friend? Ambiguous grammar. Why it is ambiguous grammar? Because for at least, see, because for at least one input string, what we have more than one parse tree. If you take this one, ID plus ID star ID, and if you want to generate this one using this parse tree, we have more than one parse tree, my dear friend. Either you can start like this, E goes to what we have, E goes to E plus E, fine. And what we have, my dear friend, and E goes to what we have, E goes to ID, and this one ID star ID, ID, E goes to E goes to E. Let me write here, E goes to E star E, fine. And what we have, ID and ID. I think it is visual for everyone, ID and ID. Fine, see clearly here. So what we'll get, ID plus ID star ID. This is one of the parse tree. And one more parse tree, what we have, E goes to E star E, E star E. And what we have, my dear friend, here what we have, E goes to E plus E, E plus E. And what we have, E goes to ID plus, see what we have, ID plus ID star ID. Fine, ID plus star ID. Fine. So my dear friend, for one input string, we have more than one parse tree. So which one will give correct answer? If I want to generate 2 plus 3 into 4, which one will give correct answer? Can you please let me know? This is 2, this is 3, this is 4. This is 4, my dear friend. So which one will give correct answer? Can you please tell me? So answer for this one, according to C rule, you know, star having higher precedence. So 12 plus 2, 14 will be the answer. But here if you will get 2 plus 3, that is what, 5. And here 5 into 4, 20 you will get. So this is what incorrect parse tree. This is what incorrect parse tree. But if you see clearly here, I think it is not visible correctly. But it is nothing but, see, it is 2, it is 3, and it is 4. So 2, it is 2, my dear friend, and it is what? 3 into 4, 12, you will get 14. So this grammar is what? Ambiguous grammar. This grammar is what? Ambiguous grammar, my dear friend. This grammar is what? Ambiguous grammar. So why it is ambiguous? See, you have a short trick also. The grammar is left recursive and right recursive. If the grammar is left recursive and right recursive, if it is happening left recursive also and right recursive also, it is what, my dear friend? Ambiguous. This implies it is what? Ambiguous. But ambiguous does not imply it is left recursive and right recursive only. Are you getting my point? If left recursive and right recursive, definitely you can say that your grammar is what? Ambiguous. But ambiguous, if it is ambiguous, you cannot say the grammar should be left recursive and right recursive. Fine. But if it is left recursive and right recursive, definitely it is ambiguous grammar. And ambiguous grammar cannot be parsed by any one of the grammar. So what you do, you convert this grammar into a equivalent unambiguous grammar. I think everyone knows that is nothing but E goes to E. Why it is happening? Why it is happening? Why it is unambiguous? Why it is ambiguous? Because here plus and star have same precedence. Plus and star have same precedence, my dear friend. That's why it is ambiguous. You cannot find here. See, sir, which one is greater one? Either star or plus, you cannot say here. Fine, you have an option here. So what you do, you don't give the option. So E goes to E plus T oblique T. T goes to what? T star F oblique F. Fine, F, and F goes to ID. Now, my dear friend, this grammar is equivalent. Equivalent what? Equivalent non-left recursive. Equivalent, my dear friend. Equivalent, you can say unambiguous grammar. Equivalent unambiguous grammar. Are you getting my point? Equivalent unambiguous grammar. Okay, equivalent unambiguous grammar. Is that clear? I think you know this is unambiguous grammar. But because we have only one parse tree, because we have one parse tree for this one, E goes to E plus T oblique T, T goes to T star F oblique F, and F goes to ID. We have only one parse tree for this one. Okay, one parse tree for this one. So for any unambiguous grammar, see, you are not, see, for any unambiguous grammar, might be you are able to convert unambiguous grammar. Fine, but there is no such algorithm so that you can convert any ambiguous grammar into an unambiguous grammar. What I'm trying to say, हर ambiguous grammar को unambiguous में convert करना, there is no algorithm. There is no algorithm, my dear friend. There is no algorithm exist. Or there is no algorithm also to find out whether the given grammar is ambiguous or not. Fine. How to find out? Some people also ask. You can solve this question Fine, you can try this question also. And before that, you can see this, sir, how to say, sir, whether the given grammar is ambiguous or not. See, if I am giving this grammar, S goes to SS oblique A. So what you do, my dear friend, see what you do, sir, it is ambiguous or not, this S goes to SS oblique A. You can try for W equal to A. So S goes to A. You can try for the minimum string. Then you can try for the two length string, W equal to double A. So what, S goes to what, SS, fine, and we have A and A. Now you can try for the W equal to triple A. So you can, S goes to what, SS, SS, and what, S goes to what, SS, and this is A, and this is A. Now we have one more pass tree, S goes to what, SS. Now this time you can expand this S, SS, fine, and this is A, this is A, this is A. Now see, we have more than one pass tree. Now we have what, more than one pass tree. Okay, we have more than one pass tree here. It is clear? Fine. So my dear friend, this question also might be you can argue with me, sir, the grammar A goes to AA slash opening bracket A closing bracket null is not suitable for the predictive parsing because of the grammar H. See, this grammar, you say, if you see this grammar, already I have given the example also. This grammar is left recursive also and right recursive also. Left recursive also and right recursive also. Fine. So my dear friend, it is not suitable. See, it is not ambiguous. You know, left recursion and right recursion, it is definitely ambiguous. Fine. It is left recursive also. Right recursive does not create any problem. We are not talking about operator grammar here. It is not an operator grammar. Fine. Because see here, two variables should not be side by side. Here A and A is side by side. It is not operator grammar. But this one, it is also left recursive grammar. And left recursive grammar also create problem. Because predictive parser is a type of top-down parser only. So might be in MS Cube, they will ask, now, maybe this year, you will go with both options. There is nothing wrong, ambiguous and left recursive. But before, when we have only MCQ, you can say, sir, ambiguous ko hum zyada priority pe rakhte hain. Ambiguous is more priority than left recursive grammar. But in nowadays, if it is MSQ question, definitely I will say you can go with A and B. No problem at all. Fine, no problem. Because dono is suitable nahi hai. Either it is left recursive and ambiguous. It will not be suitable. It will not be suitable. Okay. Okay, can you try this question? Can you try this question, my dear friend? Please reply. Try this. They have given two binary operator, upward and downwards, and they are telling with the precedence of operator down is being lower than the operator this one, means this one is greater than. Fine, upward is greater than what, downward. And they are telling this one is what? This one is what, right associative. Fine, in the question. And this one is what, left associative. And they have given some expression here. So which of the following the pass tree? I think you know. This one is greater one. So definitely it will be down. It will be what? Lowest into the tree also. Into the pass tree also. See clearly here. This operator. Fine, this operator. But see clearly here they have written down. So A will not be the option. If you see the grammar, if you see the pass tree, okay, you please tell the answer. Then I will discuss. Please reply fast. What is the answer for this one? Even though you can do like आप parenthesis लगा के भी कर सकते हो कि कौन सा पहले होगा. हमारे पास upward and downwards है तो upward पहले होगा और upward में जो right वाला है वो पहले होगा. तो इसमें देखो upward हमारा 3, 4 और 4, 3 है. तो सबसे पहले 3 और 4 evaluate होगा. सबसे पहले हमारा कौन सा होगा? 3 right associative, sorry, 4 और 3 होगा. 4 और 3 होगा. This 4 and 3. सबसे पहले 4 and 3 होगा. देखो यहाँ पे 4 and 3. See clearly, we have सबसे पहले ये 4 and 3, and the result of this one will be evaluated with this one. Fine, I think you are getting my point. And the result of this one, first one will be evaluated for this one, and the result of this one will be evaluated by this one. Fine, this one. Fine, see clearly. Fine, are you getting my point? And after that, what we have? Downward arrow, and it is left associative. So the result of this one will be what? Fine. Then after that, what we have? We will do this one. That will be the answer. Okay, I think you know. See clearly here. So first will be evaluate 4 upward arrow 3. See here, see clearly 4 upward arrow 3. Then after that, the result of this one will be evaluated with the 3. So 3 upward arrow, this one. After that with 7 downward arrow. Then after that with 2. So B for Bombay is the correct answer. Yes, B for Bombay is the correct answer. See clearly here. If you see how you can remove the option. देखो remove कैसे remove करेंगे. यहाँ बोल रहा है सबसे पहले 3 और 2 को evaluate कर रहा है. देखो यहाँ पे downward arrow. ये इसका priority lower है. That priority is lower, my dear friend. That priority is lower. I told you very clearly in the tree also. The operator which having high priority will be evaluated first. So see clearly, this upward arrow is having high priority. Upward arrow. So this could not be the option here. This could not be the option here. Fine. Now see clearly, C option, why it is incorrect if it is visible for you. C is also incorrect. Why? Because you are evaluating 3. It is what? This is right associative, but here it is left associative. That's why it is also wrong. Fine. And this one was once again 7 and 3 you are evaluating. This is also wrong. So we have B. B is the correct option. Yes, B. If anyone have doubt, you can ask me. Okay, can you please tell me? It is very easy. Bacha problem for you. Can you please tell me what is the answer for this one? What is the answer for this one? Which one of the following is true? True, they are asking. They have given the operator. They have given the operator, my dear friend. They have asked. Please reply. Everyone, please reply fast. Last option they have given both plus and star is right associative. Both plus and star is left associative. Still it is not. Okay, fine. Okay, B already given for this one also. See clearly here. See clearly. I think which is having higher precedence. Star we have and we have plus. So you know, plus is a higher precedence than star here. Fine. Now, my dear friend, if you see about this one, see, star is nothing but, see, it is left associative. It is left associative. So star is what? Left associative. And see, plus is what? Right associative. Because in right side, plus is what? Right associative. So you can check. Plus is right associative and star is left associative. Yes. So B for Bombay is the correct option. Yes. B for Bombay is the correct. See, वो बस आपको जानबूझ के ऐसा लिखा U oblique T star U कि आपको ये ऐसा दिखे, ये आपको राइट में दिखे, मतलब जल्दी जल्दी में ऐसा होता है ना, आप कंफ्यूज हो जाते हैं. तो ऐसा नहीं है, ये तो लेफ्ट में ही है ना. आप ऐसा लिखो T goes to T star U oblique U. So ये तो लेफ्ट में ही है ना भाई. It is left only. Fine. So वो ऐसा जानबूझ के दिया कि कभी कभी लोग जल्दी में गलत कर देते हैं ना, जब भी वो आप कंसंट्रेट नहीं रहते हैं. So you do wrong here. Fine. So you should don't do silly mistake, please. You people don't do silly mistake. I think we have done this one. We have done this one, I think. Yeah, we have done this one already. Okay, can you please tell me what is the answer for this one? What is the answer for this one? Last question we have already done. Fine. We'll see in SDT also. Fine. This is nothing but they have written the SDT. Grammar along with some rule. Grammar along with some rule. But you can solve here also. Grammar along with some rule they have written. And they have asked you, what is 2 hash 3 and 5 hash 6 and 4. See, generally this question will be numerical answer type. Generally. Option नहीं भी दिख रहा है तो कोई दिक्कत नहीं है. But that kind of question will be, my dear friend, numerical answer type only. Fine. And you can replace the hash meaning they have given. Multiplication. Okay. And meaning they have given. Hash meaning is what? Hash meaning is also multiplication. And meaning is also multiplication they have given. Okay. But what you do, just I'm changing a little bit for you. I'm just assuming this is plus. Fine, I'm assuming this is plus and I'm assuming this is multiplication. This is plus. I'm telling E goes to E has T, it is nothing but plus. I'm telling it is plus and this is what? Multiplication. Okay, this is nothing but, see here, E dot value equal to E1 dot value plus T dot value. Fine, this is nothing but T dot value equal to T1 dot value star F dot value. Fine, this is plus, this is a star. So you can just, hash is nothing but plus. So 2 plus 3 and is multiplication into 5 plus 6 into 4. Fine, that is the meaning of this one. Okay, now rest of thing you know. बाकी सारी चीजें आप जानते हैं. मीनिंग बताया, E goes to E has T का मतलब क्या है? ये प्लस है. और t goes to t star f का मतलब क्या है, ये मल्टीप्लीकेशन है. ओके, and this grammar, see here, this grammar is left recursive. Sir, even me, only for distinguish they have written e and even. It is left recursive only. It is right, it is left recursive only. So plus and multiplication is what? Left recursive. Means plus and multiplication is what? Left associative. And which one is having higher precedence? Multiplication, because multiplication is farthest from the start symbol. E is the start symbol. So multiplication is greater than what? Plus. Greater than what? Plus. Maybe they will change. They will write plus here and multiply here. Then it will be changed accordingly. Fine. Then it will be changed accordingly. Fine. So if you solve this one, what will be the answer? Can you please tell me? The answer will be what? See, multiplication have higher precedence. And multiplication is what? Left associative. So you can multiply this one first. Fine. After that, this one first. Either it's here. So 3 into 5. It is nothing but 15. Fine. And plus 6 into 4. It is nothing but 24. Fine. 24 and nothing but 2. So what is the answer? 17 plus 24. So I think it is nothing but 41. 41. 41. Fine. Let's suppose if it is plus and if it is star, then my dear friend, then the answer will be changed. As per grammar, my dear friend. Fine. As per grammar, my dear friend, answer will be changed. So I'm not assuming this is GATE 2000. I have changed little bit. Fine. According to this question, the answer should be 41. The answer should be 41. Okay. According to this one, I'm assuming this is plus and this is a star. In GATE might be something else. Okay. You should know the concept. Fine. Those who are near to the start symbol having what? Lower precedence. And those who are farthest from the start symbol having higher precedence. Okay. Okay. If I will change, then answer will be changed. Fine. Are you getting my point? So my dear friend, I told you every time, test series is very important. Please join the test series, because definitely if you do some silly mistake also, fine, it will rectify in test series. Fine. And psychologically also, like, you are not feeling you are giving GATE exam like on the actual date. Fine, you are feeling like you are giving test series only. So it will be definitely it will be beneficial for you. And 27 September, fine, 7:30 p.m. last 120 days preparation strategy to qualify GATE. You can join with Richa Gupta ma'am. And if you want scholarship test, more scholarship test, maximum scholarship test, my dear friend, you can give the scholarship test. That will happen on 24 September 9 a.m. to 9 p.m. You can register. Description दिया हुआ है. Fine. Link दिया हुआ है description के अंदर. Fine. वहाँ पे आप जाके देख सकते हैं. Fine. और this course has been already started. If you want, you can join this course. And this is my Telegram link. Fine. If you have any query here, you can please ask me. And yeah. Fine. And please like and share the session. Fine, if you like. And if you have any question, I'm giving you 5 minutes. You can ask me. Do you have any question? See, in this class, what we have discussed about grammar. I told you grammar have 4 tuples: VTPS, variable, terminal, production, and start symbol. Fine. Then I told you grammar can be ambiguous or unambiguous. So see, if the grammar is left recursive and right recursive, it is definitely ambiguous. Fine. And some ambiguous grammar you can convert into an unambiguous grammar. You cannot convert every ambiguous grammar into an equivalent unambiguous grammar. It is undecidable problem. Fine. Finding ambiguous grammar is also an undecidable problem, my dear friend. Okay. And thereafter we have seen like what is left recursive grammar, what is right recursive grammar, and see if it will meet to the top-down parser. If left recursive grammar meet to the top-down parser, it will go into the infinite loop. So we'll convert the left recursive grammar into an equivalent non-left recursive grammar. Fine. Equivalent means, see, meaning should not be changed. Fine. Are you getting my point? And after that, we have seen some question based on my dear friend your grammar part. So tomorrow, my dear friend, we'll see top-down parser, and maximum question will come from LL1 also. So first and follow. If you know correctly, first and follow. You are able to give any question? Ask in in parser part, because in parser, if you find first and follow correctly. Because first and follow will be used in bottom of parser also. So if you know first and follow correctly, your parser will be over. And if your parser will be over, your 2 marks will be पक्का. 2 marks आपको पक्का मिलने वाला है, वो कहीं नहीं जाएगा. और parser बहुत आसानी से आप 2 नंबर यहाँ से ला सकते हैं. I have selected second paper combination. paper combination, primary CS and secondary DS, and so yes, there is a difference, Satya. Fine, DA paper and computer science paper. Fine, some part are same. You can say like in DBMS also, like DBMS, some part are same, and they have used in data science. They have used what you say, like data warehousing. They have used in DBMS part. In data science and AI, you have to more focus about mathematics part. Fine, mathematics part. More focus about probability part, permutation and combination part. Because if you know mathematics properly, definitely you are able to score good in both, in computer science also and in data science and AI also. So first is mathematics. Thereafter you can learn for like Python plus machine learning and DBMS. DBMS is common in both, but in data science and AI, we have extra called data warehousing, and we have AI part also. We have what AI part also. Maybe like, yes, it will not be same day. Maybe next week it will be. Like, it is not like they will put on Saturday and Sunday. I think they know like many people are filling both papers. So maybe like 1 week gap should be there. 1 week gap should be there. Don't worry. 1 week gap should be there. ठीक है, you can आपने फॉर्म अगर नहीं फिलअप किया, you can please fill up the form fine as soon as possible because date like अभी date close होने वाली है. Fine. So tomorrow be there everyone. Please join tomorrow at 9 p.m. Fine. Sunday also we have a class. Fine. Tomorrow and 7 p.m. and 7 p.m. my dear friend on app. Fine, app. 7 p.m. on BYJU app. It is free class and 9 p.m. on YT. 9 p.m. YT. I will discuss tomorrow LL1 problems. I will discuss tomorrow LL1 problems. So please join me tomorrow. Fine. Last date is, I think, 29, if I'm not wrong. Shantanu, last date is 29. 29th of September, I think. 29. So लास्ट डेट का वेट मत करो. बहुत लोग लास्ट डेट का वेट करते हैं, मैंने देखा है. फाइन, एक दिन पहले फिलअप करेंगे. और उसमें गलतियां हो जाती हैं जल्दी जल्दी में, क्योंकि गलती होने पे भी इस बार पैसे ज्यादा लगेंगे. शांतनु, फाइन, अगर गलती होगी नाम में या डेट ऑफ बर्थ में या फादर्स नेम में, तो आपको एक्स्ट्रा पे करना होगा मॉडिफिकेशन के लिए. 500 या समथिंग रुपीज हैं, सबके लिए दिया हुआ है. आप जाके एक बार ब्रोशर देखो, ISC बैंगलोर जो नोटिफिकेशन निकाला है. फाइन. सो इसलिए अभी टाइम है, आज आराम से फिलअप कर लो. कल संडे है, कल आराम से फिलअप करो बैठ के. फाइन. और आराम से इत्मीनान से फिलअप करने की जरूरत है. फाइन. सो इस क्लास में थोड़ा मैं जल्दी इसलिए रहती है, मैं कॉन्सेप्ट को आपको टच कराना चाहता हूँ, रिवाइज कराना चाहता हूँ. मेरा मेन मोटिव ये है, और हम प्रॉब्लम को सॉल्व कर पाए. ठीक है. फाइन. मे बी someone is not aware about grammar and like ambiguous grammar, left recursive grammar, right recursive. Maybe you feel difficulty, but if you have a little bit idea also, this class will help you. This class will help you. Okay. Please like and share the class. Thank you so much. We'll meet you tomorrow. Thank you for your time. Just one minute.